Hello all. So in the previous video we have seen how we can delete a node at the beginning of a linked list. Now in this video we're going to see how we can delete the last node of a linked list. Let's suppose we have this linked list and it consists of 4 nodes. So the fourth node will be our last node to be deleted, and we have to delete it from the linked list so that at the end we are having left with 3 nodes. Let's say this is 10, 200, 20, 330, and then 400, and then 40, and there will be null in the last node as supposed, and this is our head pointer that is pointing up to the very first node in the linked list. Okay, so now the requirement is that we have to delete this last node from the linked list. Now, to reach up to this node, we need to traverse up to here, right? And when we encounter that the next of the node contains the null, that means we have reached our last node. Okay, and at that point we need to delete it from the linked list. That means we need to free up this space, and in the previous node we need to fill the previous node pointer as null so that this link is broken. Okay, we need not to update anything with the head. Just here we need to make it as null so that this link is broken. Okay, so for that we just need to have a pointer pointing to this also, right? Because if we'll move up to here, like if we move up to here we can delete, but we can't access back because it is just a forward link. Okay, so we need to keep a track of this node as well, just before node that we have to delete. Okay, so this is some of the requirements. Let's see this how we can code this as a functionality. So let us begin like void delete at end. Okay, as usual we are going to provide the head pointer so that we can traverse up to the last node. Right, now we need, I already told you that we need 2 pointers, one to keep a track of the last node that we have to delete, and one to keep the track of the last node that we have to delete, and another pointer to keep a track of the immediate before node, immediate last node just before that, so that we can update the pointer, the next pointer as null there. Okay, so this is very important because when we keep on moving ahead we can't come back since it is a singly linked list. Okay, okay, now let's have the 2 pointers that are the node pointer p and pointer q. Right, so these are our pointers. One basic check that if our linked list is empty, that is if head equal to null. So if our linked list is empty, what we are going to do, we are just going to print a statement that we can't delete because the list is empty, so that the user would be knowing that since the list is empty we don't have a choice, right? So this is the very basic check. Now let's say we have only one node in the linked list. So this is also a very important condition to be checked, because if there are only one node, that means that it is similar to delete at the beginning or delete at the end or delete at some position. Just one node we have to delete it, and we have to update the head pointer, right? How we can check that? If head next equal to null. That means if there is only one node in the linked list, then we are gonna free the head, of course. We are going to free the space allocated, marked by head, and we are making the head as null, right? So these are the basic steps when we have only one node in the linked list. Okay, this is important. Right, now let's say we have two or more than two nodes. Now then the condition of the end part comes up. Okay, So what we are going to do, we have already declared two pointers, node pointer P and pointer Q. So what we are going to do, we are updating our pointers. First, we will place the pointer P as null, and in pointer Q, we are placing the head, right? Okay. So this is just two pointers moving along. I'll show you how. So while we are just traversing via Q, this is our traversal pointer. Okay. So while Q next of Q not equal to null. So this will move up till this pointer. This Q will move up till this pointer, because when next of Q becomes null, we come out of this while loop, right? So we have to place P somewhere before a Q. Okay, so when we come out of the loop, Q is pointing to the last node and P is pointing to the last before node. Okay, so that is important. That is why we have declared here two pointers. Okay, very, very important point to note. So Q is pointing to head while Q next not equal to null. So if Q next not equal to null, Q is initially pointing here, right? Q is initially pointing to the head, that is to the first, right? Then Q is pointing to the next, so P equal to Q. P is also pointing now to the head, okay? And we are moving Q equal to next of Q. So here in these two statements, you can see that P is pointing to head and Q is pointing to next of head. So in one single iteration, initially P and Q are both at the same. Now Q points to next and P is still pointing to the head. Okay. And it will see again that Q next of Q not equal to null. Of course, next of Q is not equal to null. Okay. This is not equal to null. So we are making P as Q and Q will be pointing again to the next. Okay. Now again we are checking in the next iteration if next of Q not equal to null. Correct. So P will be pointing here, right? And Q will be pointing to this. Now we'll check. Now Q is pointing here, P is pointing here. Now we'll check while next of Q not equal to null. So next of Q is equal to null. We are coming out of the loop. Q is pointing to the last node, P is pointing to the last before node. Okay, so this is important. That is why we are keeping track of the previous node. Okay, now we are coming out of the loop. Now we have the P pointing to the last before node. So we will place next of P equal to null, and since Q is pointing to the last node, so we are freeing up the space pointed by Q, right? And we are placing null in Q and null in P, because now we don't need any additional pointer to point to the last. We can traverse to the entire linked list via the head. So this we are doing for just to avoid any unnecessary pointer pointing up to any of the node. Okay, so this way we can delete the last node from the linked list. Thanks for watching. That's the end of this part, and in the next upcoming video we are going to look up to how we can delete a node at a given specified position in a linked list. Thank you.